Welcome everybody, this is my FEA tutorial on how to model, simulate, and analyze a Softail mountain bike in Abacus. As you can see, we're starting in SolidWorks. I found that was easier to model the bike, generate a point cloud, and then port that data over to Abacus. So first we're going to start by creating a new sketch. I'm going to just put it on the top plane here. And then the tool I'm going to be using in SolidWorks that makes this super easy so I didn't have to take a million measurements is in Tools, Sketch Tools, and Sketch Picture. So here it'll open up some of the photos I have. I'll use this guy right here. So now that that's open, the first thing I'm going to do is rotate this. You can see that the photo is not quite perpendicular to the planes I have in SolidWorks, so I know that this has to go about 4 degrees. Next, I'm going to zoom in, and this bar right here is just to help you scale the image. So I'm going to drag each point to each end of the ruler, and then it'll ask me to input a distance. So now that I've dragged both of those points, it's going to prompt for a dimension here. We all know a ruler is 12 inches, so I'm going to put 12 in there. And English is the units I'll be working in for this. So now that we have that scaled, I'm going to drag this so that the origin is in a convenient spot for me. Somewhere, I would do it somewhere just so you have a reference point. For me, I'm going to drag it to the corner of this bottom bracket here and just get it pretty close. So now I'm going to accept the changes I just made here, and now we can just start drawing lines. I'm going to start over here and get the bottom bracket modeled. So I just drew this first line. I'm going to get another one going here, and I'm going to snap it to the midpoint. And now that's just an easy way for me to tell what is essentially the center of that bottom bracket. From here, I'm just going to kind of draw out some lines that look about right. So as you can see, the lines are blue, so they're not fully defined. What I'm going to go in and do is add a couple more lines and fully define this sketch. Another thing you can do as well is it makes it easier to, I'm going to accept this here, makes it easier if you want to turn down the opacity of this or the transparency. So we'll go to feature properties, full image, and you can change the opacity there. That looks about right. And then when I go back in and edit, those lines pop a bit better. It's a bit easier to see. So I'll be back with a fully defined sketch. Alright, so now I have this full thing dimensioned here. And what you're going to want to do is take a screenshot or save some sort of image like this, because these dimensions will help you gather data for each point. So we're going to hop into Abacus and then create some datums for these points. Alright, now that we have Abacus open, I'm going to make a new model with the standard explicit model here. I'm going to go in and make a new part, and it's going to be 3D deformable wire. That's important because I want to use beam elements. I am going to sketch the first part that I just made there in SolidWorks, and the rest will be the same. So what I'm going to do is click this here, and here you can enter all the dimensions for the those datum points. Alright, so what I've done here is input those points. You can see those are the pink parts here. Let's move over to that right there. And then what I did is just connect each one of those lines, each one of those points with a line, just like so. Next thing we want to do is, once we have one sketch, we can start editing in 3D now. That was just on a 2D plane. So what I'm going to do is I have all the coordinates for my other components. What I'm going to do is go to right here, and I'm going to create a datum point, and I'm just going to start entering in all of those values. I'll put this in as just an example. So we have 0, 0, 0. If I just hit enter, you can see that datum point shows up. How you connect them is you go here and then you scroll over to this guy. Here I want to disjoint the wires. That just means you won't click and it'll start creating a chain. I'm going to hit plus here, click on my first point, and then my second point. I'll hit done. And so now we have a bunch of 3D points that are connected by lines. And these are all wires. So I'm going to build the rest of the model and come back when that's done. To make the dropouts of the bicycle, I went in and I created a new part. I'll call this dropout, made it 3D, deformable, and a shell, and used the planar type. Here I just made a simple rectangle, and then what I did was just took a circle here. Finally, I trimmed the unused pieces. Now we're going to exit, and here we have our second part. After this, we're going to want to add this to the model, or the assembly rather. So I'll come into here, I'll create an instance, insert the dropout, and hit OK. I'm going to grab this tool here, click on the part I want to translate, and then click on a point. So that point is going to be translated to this point here. That's not exactly the position I want it, but it tells the story. Now to get the other dropout in, what I'm going to do is a linear pattern. Click on this here, select the instance I want to pattern, and then the offset. So now we have two dropouts in the places we want. Now to connect these together, here I'm going to use a tie constraint. So now we have a tie constraint on this, and then we're going to do the same thing on this. Once we have that interaction set up, we can start going into our loads. So now to simulate the spring and the shock, what I'm going to do is come over here to the engineering features, right click, create spring dashpot. I'll do connected at 2 points, and then select this gap here. Hit done. I need a spring stiffness about 300 pounds per inch and a dampening coefficient of 1. One specialized boundary condition I want to set up is here on the shock. So what I've done is created a coordinate system here. I'm going to add a new boundary condition and make a new datum axis. So we'll go into boundary conditions, create, I'll do displacement and rotation. I'll apply it on the initial step, hit continue. So first I'll grab a point and then a second point, and you can see that that X axis lined up with the line of action on this. I want to lock everything except for the X. So now that is constrained so that it can only move in this straight line here. Next thing I want to do is lock the seat tube. This is just to recreate how it would actually be on a bike if we had modeled the full thing. Awesome. Now what we have to do is apply some loads. I'm going to create a few steps here. I also want to turn on this nonlinear geometry on the apply rock load. I'm going to create a load. I'll do a shell edge load. I'll put in a magnitude of 100 pounds. Next, I'm going to create another boundary condition. And I want to simulate the bike going over about a 1-inch rock. So that'll be in the positive Z direction. On the release rock step, I want to deactivate this. So essentially the bike is experiencing a displacement and then rolling over it. Finally, we want to go into the mesh. Here you can play around, but what I've done is selected this and hit certain lines such as this, applied a bias. Where there are intersecting points, I want more nodes. Next, we'll mesh the dropout. Here I've already done that. I'm using quad elements, and I did this in a similar way where I seeded edges that are going to experience more stress. So now we should be ready to run the job. So now I'm going to go to the deformed shape, click this option, and scrub through to see if my thing is displacing. As you can see, we're getting some oscillations of the rear shock, as well as some deformations that make this look similar to a wet spaghetti noodle. And now that the simulation has essentially started to crash my computer, I'll use Task Manager to shut it down.